Probability practice exercises 68 through 71. In a lottery game, a player picks 6 numbers from 1 to 48. If 5 of the 6 numbers match those drawn, the player wins second prize. What is the probability of winning this prize? So if we are going to look at all the different ways that we can choose 6 of those lottery numbers from 48, that's 48C6. Okay, now we're just talking about second place. So of the 6 lottery balls, we're only choosing 5 that are correct. All right, so we don't have all these balls accounted for, and this is out of the 6. So we also, of the remaining 42, we're choosing 1. Now, if you do 42C1, you're going to get 42 regardless, but I just think this visually helps us see what's going on. So multiplying across, we get 252 in the numerator, and we get 1,712,304 in the denominator. So maybe you can figure out on 69 how we're going to set that up. In a lottery game, a player picks 6 numbers from 1 to 48. We're looking for a probability again, so we know that we are choosing a total of 6 numbers. And this right here, it's all the different ways you can choose 6 from the 48 numbers. If 4 of the 6 numbers match those drawn, so this is 6 of the winning numbers, and we're only choosing 4 at this case, the winner wins third prize. So we need to figure out of the 42 remaining, we're choosing 2. So those are all the different ways that can happen. So multiplying the numerator across gives us 12,915. And I think you can figure out that our denominator would stay the same as it did for number 68. All right, 70 and 71 should go pretty quickly for us. Compute the probability that a 5-card poker hand is dealt to you that contains all hearts. So standard deck of cards has 52 cards in it, and we want 5 cards. We want a hand that has all hearts. So there's 13 hearts, and we want 5 of them. Now you're like, well, where's the rest of the cards? Well, I don't win any of the other cards, right? So we're done there. So 13C5, looking in my notes here, there it is 1,287. And that's going to be over 2,598,960. All right, number 71. Compute the probability that a 5-card poker hand is dealt to you that contains 4 aces. All right, this is going to be a little different. 4 aces is not going to count for all the cards, right? So I need 4 aces. I'm going to need 1 other card, okay? So there's a total of 4 here for the aces. And so what I have left is for the 1 other card, we're going to have 48 other cards, right? Okay. So to set up our probability, I think we already know what the denominator will be. So that's going to be the 52C5. Of all the 4 aces available to me, I want all 4, okay? Of all the other 48 cards out there, I want 1. Now, these you might not even have to put in your calculator as combinations. You might be able to tell what they are just by looking at it. 4C4 by now, hopefully figured out as 1. 48C1, hopefully you figured out by now would be 48. So multiplying those together, you get 48 over 2,598,960.